Alright, what's up guys? Got a little bit cleaner of a setup going on right now. Finally remembered the whiteboard. I've got one of my vices set up to hold it in place. And we're going to talk about battery characteristics, particularly capacity, charge rates, discharge rates, basically the C ratings. This is just basically going to be, battery basics, I guess. To start with, before we get into what I've got here, I finally found a way to mirror my, because I use my phone for my camera. It has an excellent front-facing camera, or a rear-facing camera. It will do up to 4K. Only for 10 minutes. So even in full HD, full 1920 by 1080p, really high quality image. But it's a huge pain in the ass to use the phone with the front facing camera, like with the rear facing camera, like I am now, because I can't see what it sees. I don't know if it's freaking out. I don't know if I get a text message and it stops. I've got most of the freaking out issues sorted out, but I still couldn't see the screen. So I found a little bit of software that lets me link it to my laptop, which is actually right there. I'm looking at it right now. So I can actually see exactly what the camera sees on a full screen, full-size laptop screen. Just makes life better. Makes it much easier to tell what my camera's doing, and I actually have full control of my phone from the laptop, as well as being able to see exactly what the phone's screen is displaying. So it's nice. I can actually control all the focus and all that crap, and you guys don't have to see it. Next step, which hopefully I will be ordering this week, is I found a wireless microphone for my phone, a lapel mic or a lavalier mic, whatever the heck you want to call it. Found what looks to be a very decent one, very nice one. The Bluetooth headphones were great, but they pick up every little tiny noise and all the little bullcrap that's going on. Cars driving by. I don't have a legitimate studio to do this in. I have basically, as you can see behind me, I've got a tarp hung up to try to help adjust things. I've got pretty substantial light setup going on back there to try to help increase the video quality. And obviously a lot of the things that I do, this setup will not work. I've got this setup where I can roll the tarp up out of the way, and it's not a tarp I was using for anything else. But for videos like this where I'm going to be sitting here, this will be fantastic. The lapel mic, the wireless mic, will help tremendously with the audio quality, I feel. We'll see how it goes when I get it. If you guys know of any good software for video editing, please let me know. I've downloaded a couple and I've been playing with them a little bit. I am currently working on a new project, which I will post that video up hopefully in a day or two. I'm still working on, it's actually going to be edited slightly, probably more than slightly, but anyways, it's going to be huge, literally, when it's done. So stay tuned for that. It's going to be pretty impressive. So, if you already know all of this information, if you already have been using for lipos for any extended amount of time, or lithium batteries, or really any, what would you call it? If you've done any kind of electric RC car stuff, you should have a fairly good understanding of the batteries. If you've been vaping for any amount of time, I sincerely hope you have a decent understanding of lithium batteries. However, there are some things that a lot of people that I know that are very experienced in the vape scene do not know about the batteries. and it was requested, so I figured, what the heck, we'll sit down and we'll talk about specifically lithium battery basics, but everything I'm going to be talking about can basically be applied to any battery. The C rate, which is used for discharge and charge, is used basically as a multiplier to determine charging rates and discharging rates of the battery. That is the sole purpose of the C rating of the battery. All the information on this applies directly to this LiPo, which, hey, you can actually read it now. Check it out. 6,200 milliamp hour, 40C, 7.4 volt. This is a 2S. This cell actually failed because I left it hooked up to a computer fan for too long, and it over discharged. That is a huge difference between quality A grade lipos and B grade lipos, which is the fluorions. These are still technically capable of all of their ratings, but these are considered B grade. It's the equivalent of an EFEST 18650, and before you even get started, EFEST is not a manufacturer of batteries. They rewrap and then charge more. Show me a manufacturer for EFEST, show me an actual plant where EFEST produces batteries, and I will take it all back. EFEST is not a manufacturer of 18650 batteries. They rewrap B grade batteries and re-rate them. I don't care. I don't care what you have to say about that. I'm not saying they're not quality, because they're B grade, but they don't pass the manufacturer's specs for their top-notch batteries. This is Fluorion actually makes their own, but they are considered a B grade LiPo or B grade lithium pack. You can actually see how swollen that is. It still takes a charge up to within 0.02 of a volt of full charge. It still has most of its capacity, but using this for anything other than very basic, like running a LED light strip or something, I haven't used this in a couple weeks since it happened. I could still use it, but the odds of it failing at this point are much, much higher. It has already been damaged to the point that really it needs to be recycled. I intend to tear this apart and test each cell individually, and I know that the only cell that's damaged is this one on the edge. These batteries are 2 series, 2 parallel, so I should be able to pull 3 good cells out of this. Maybe, we'll see. If not, I'll recycle it. It's very good to recycle your old cells if you've got them. Put you a little spot to the side. If you don't know where you can take them to recycle them, if you live in the States, Best Buy, you can take them up to Best Buy. I believe it's Geek Squad will actually take them and recycle them. There are also other places that you can take lithium batteries. You can look it up online and find places local that will recycle lithium batteries for you. So, let's get into this. This battery is 6,200 milliamp hour, 40C, 8.4 volt battery. Fully charged 8.4 volts. We're going to do all the measurements off 8.4 volts because that's the absolute maximum it's capable of. At 40C, that's something else. You've got continuous discharge ratings, which is what I am basing this off of. Fluorion on their website has this LiPo rated for 60 amp or 60C pulsed. They do not give the pulse specifications. They don't tell me if it's for 10 seconds or 5 seconds or 2 seconds or a half a second. That is something you have to know. You can calculate what the battery can run pulsed, but unless you know how long it's rated to run that pulse, it's really useless. So that would basically be your absolute maximum cannot exceed pulse rating ever. So what we've got, 6,200 milliamp hours. That is also 6.2 amp hours. You got a 1C charge rate is just the standard across any lithium batteries. most chargers are designed to run at a half C or 1C. My XTAR 2-bay 18650 charger is a half C. With my Sony's, it's a 0.75C with my HB6s. So there is some, it's rated at a half amp and a 1 amp per bay. So depending on the battery you use, if you're only using a 1000 milliamp hour battery, it's only going to be a 1C. Why is that? You multiply the C rating by the amp hours. For charging, 1C times 6.2 amp hours gives you 6.2 amps. To charge this battery at the standard 1C rating, you have to give this 6.2 amps. At 8.4 volts, that would give you a maximum of 52 watts. Any good LiPo balance charger will charge at constant current, which is basically, if I set it, mine does 5 amps. So if I set it at 5 amps up to approximately, well, it adjusts the amperage accordingly, but in constant current mode, it will run 5 amps up to whatever the internal voltage limit is set at, somewhere around 8 volts. Once it reaches 8 volts, it switch over to constant voltage mode and will run 8.4 volts and slowly cut the amperage down until it's down to 0. At that point, the battery's fully charged. It effectively is trickle charging it once it reaches constant voltage. That's not the best explanation in the world, but that's all I can give you without erasing all of this. The discharge rate is 40 Cs on this, so 6.2 amp hours times 40 C gives you 248 amps, continuous at 8.4 volts. Like I said, we were basing this off of the full charge of the battery, the full charge voltage, purely because that's the maximum voltage of the battery, so that is the maximum continuous discharge that this battery is designed to run. At full voltage, that's 2083.2 watts. If you hook this up to a 2000 watt load, excuse me. Well, let's take a step back here. I posted a video as proof of my 1000 watt build. It is in the channel. I may link it, I may not, I don't know. In that video, I hooked up a voltmeter to the posts of the atomizer to check the actual voltage at the coils, and then I hooked up an amp meter to the output of the battery. That was a 3S LiPo, and it ran, I believe, I'm trying to remember, it was like 11.1, 11.2 volts, just over 90 amps, which was within the LiPo's range. That included voltage drop. That was the voltage at the coils and the amperage the battery was putting out. Depending on where you measure in the circuit is going to affect that reading. Measuring at the coils gives you the most accurate actual consumption. But measuring at the battery gives you the actual output, tells you what the battery's actually putting out. If you measured amperage and voltage at the coils with a 2S LiPo and you're only measuring 7 volts and you're only getting 100 amps out of it, that's 700 watts at the coils. Oh wait. If you measure at the coils, you get 7 volts and 100 amps. You're getting 700 watts from the coils. But if you check the battery, and the battery's telling you it's got 8 volts and it's still putting out 100 amps, then you're pulling 800 watts. You've got a 100 watt power loss, and that's exaggerated, but that is what you are testing when you're testing voltage drop, is the load from the battery to the coils. That is what you are measuring. I think I'm getting a little ahead of myself. But Based on the C rating, this battery should be able to supply 2,083 watts continuously without exceeding its ratings. They claim, Florion claimed that this battery is a 60C pulsed. If you did that, if you actually said that it was a 60C, then you would have another 124 amps added onto that. So you'd have what? 372 amps and another 1,000 watts, 3,000 watts is what it would be capable of pulsed. If you're actually pulling 3,000 watts off of this battery, I would not be surprised if the voltage drop was just tremendous. Though it would probably do it for a short period of time. So, let's just... Where's my... Oh! I dropped my marker here. The formula for determining the battery's discharge rate is amp hours times the C rating gives you amperage. This applies to any battery, regardless of what chemical makeup it is. You can use this on a AA if you wanted to. I think they average like 2,600 milliamp hours for a Duracell, or 2,100 milliamp hours. Pretty substantial. The C rating is super low on a AA battery. Lithium battery is much higher. I think a Sony VTC4 is, I know it's 2,100 milliamp hour and 30 amps rated. So to get that, you would say 2.1 amp hours times what to get 30? I can't keep up that math that quick in my head. I don't know, 30 divided by 2.1. So, 1, 9, about 18C approximately. We'll just say 18C. I think it's actually just over 18C. So you can actually, by knowing the actual amperage and the amp hours of a battery, you can determine the C rating. What use is that? That gives you the ability to very quickly and easily compare two dissimilar batteries. You can compare the power ratings of a lithium battery against the power ratings of a nickel metal hydride battery, or you can compare a LiPo against an 18650 lithium ion battery. Such as my HB6, my LG HB6s that I use, they're 18650s. They are only 1,500 milliamp hours. .5 amp hours. They are also 30 amp batteries. So 1.5 times 30 is 20C. So they actually have a higher discharge rating than the VTC4s with the same current rating. You could say, if I wanted the same power output as this battery, but I only wanted half the capacity, if I need a smaller LiPo, I could get a 3,100 milliamp hour 80C, and it would give me the exact same amperage. It would only last half as long as this battery, but it would give me the same power output. So you could compare, I can say, okay, my LG HB6s are only 1.5 amp hours, 20C, whereas the VTC4s are 2,100 milliamp hour, 18C, approximately. I think it's like 18.7 or something like that. You can compare batteries without having to say, okay, this one's a 2,100 milliamp hour 30 amp, this one's a 1,500 milliamp hour 30 amp. What's the difference? Why would you want a lower capacity battery? Well, there are a lot of reasons. Higher capacity means higher internal resistance. There's more inside the battery, so you have more resistance. So a lower capacity battery with a higher discharge rating typically will have lower internal resistance and will run cooler. My LG HB6s do not get nearly as hot as my VTC4s under heavy load. Not even close. They don't last nearly as long. There's a huge difference in the battery life, but they don't get nearly as hot, which allows me to use them under load better than I can the VTC4s. They don't have as much voltage drop either. I know it's a lot. It's not incredibly well organized. I tried to organize this for you guys a little bit. I have run long on the video as well. But that is battery basics in a nutshell. And probably a little bigger of a nutshell, probably a walnut. I do have a big project. Mentioned it. I haven't decided if I want to start posting them in parts, posting what I've got done in parts and videos, or if I want to save it all till it's finished and then post the videos individually, or just do one giant video. Which would you guys prefer? I know long format videos, more than about 15 minutes, I generally don't watch it. And that's shown in the YouTube analytics. It shows, I think the average view length for my videos is like 1.5 minutes, 1.50 seconds. So not very long on the average there. That's across all the videos on my channel though. So what do you guys want to see? Do you want to see shorter clips of me building it? I do plan on showing all of the machine work, whether it be really fast forwarded or all of it in real time. There's a lot of time involved in machining, especially with the equipment I've got. So if you watch it long, just one little part that I made this weekend, I spent I recorded for 15 minutes and I worked on it for about an hour and a half. And it came out terribly. Well, no, I've got a good half hour worth of recording on it. Tell me what you guys want to see. Tell me how you want to see it shown. It's going to be big. Don't know exactly how big, but around 70 millimeters. Just depends on how the parts machine, how much material I've actually got. Anyways, I hope you guys enjoyed. If you have any other questions about the lithium stuff or about the batteries in general, please feel free to ask, comment down below. I'm more than happy to answer any questions you've got. There was something else I was going to say, and I done forgot. And I even remembered the whiteboard, but I didn't get to write it on there. Crap. I've got to change the cotton out in this thing. It is long past due. And it just doesn't taste near as good in this. Sour banana and both of them, same fluid. And it tastes so much better out of that, even with the worn out cotton. I'm going to have to fix that. I almost hit the foot pedal. Better turn that off before I do that. Anyways, let me know what you guys think and vape on.